This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we support design engineers and make lightning protection easy. You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. Welcome back to the Struck Podcast. I'm your co-host, Dan Blewett. On today's show, number one, we're going to talk about Oxford University has a interesting report out, says they can make jet fuel from atmospheric CO2. So really interesting development. We'll chat a little bit about that. The Cessna Citation is now 50 years old, coming up this year in 2021. So we'll talk about why that's important with this monumental little plane. We'll talk about Venus. Does lightning strike on Venus? These are good questions. In our engineering segment today, we'll talk about agile engineering, which is obviously a sort of a mainstay in Silicon Valley. Move fast, develop your prototypes. The saying "move fast and break stuff." Does that really apply to maybe the eVTOL market and air travel in general? Probably not. And then lastly, in our eVTOL segment, we're going to talk about Elbit and a bunch about Lilium, which a lot of really interesting news in the news cycle recently with them. So Alan, first let's start with Oxford University. So they said they can use iron to turn carbon dioxide into jet fuel. What's your take on this?
Well, there's been a number of different ways to make fuels from, and you see some of this on television, where they've used algae to make hydrocarbons or a catalyst, like in this Oxford study, it was a catalyst to create jet fuel. So there's a number of different ways to create hydrocarbons. The question is, is it cost effective or not? And at this point, the catalyst method hasn't been very cost effective, or has used some rare earth metals like cobalt to do it. This uses obviously a lot cheaper materials to do it, but it's an energy intensive process. Is it cheaper to do it this way, or is it cheaper to refine petroleums to get to the jet fuel? It's going to take time on both sides. I know there's a big push in Europe to make clean, quote unquote, cleaner fuels. This wouldn't necessarily be cleaner, but the carbon dioxide that goes into it is the carbon dioxide that comes out of it. So I guess it's carbon dioxide neutral, if that's an advantage.
Yeah.
But what's the cost, right? Airlines spend so much money on fuel right now. If you doubled or tripled that, you would put airlines out of business. A number of them would go out of business. Can't afford it. So there's a lot of more work to do there. It is a good sign, but I always, when I see these, I always think, all right, there's got to get some scale to it and see if you can drive down the cost, just like Tesla's doing on like the Gigafactory for the batteries. They're going to drive down the cost because they're going to produce them at massive scales. This hasn't been scaled up yet. They're still in the laboratory. So you're at least 5 to 10 years away from having something real, and then another couple of years away before the certification authorities would even let you use it. So it would take a while.
And is that going to be chased out of the equation by electric power, by hydrogen? Obviously, we talked a bunch about hydrogen fuel cell technology. This being 5 or 10 years away from any kind of viability, is it even worth chasing?
I don't think so, unless there is a huge cost savings. Like when they sat down and ran through what it would take to do this on an industrial scale, could they make it less expensive than hydrogen? I doubt it. Hydrogen will be really simple to make. We all know how to make it using electricity. You just break the bonds, and then you got hydrogen out of water. It's energy intensive, but if you have extra energy to use, the system to make it's not very complicated. And we all have a lot of history with hydrogen on the engineering side. So hydrogen is probably the easier answer. There's a lot of hurdles. And I think the one thing people don't realize is that the certification authorities and the engine manufacturers dictate what fuel you can put in your aircraft, right? Because there's a lot of risk with a fuel that damages the engine in some way. Like we've seen recently with some of the additives to stop algae growth, that too much of that is bad, too little of that's bad. So all the little additives and things to make fuel burn properly in jet engines is super critical and is approved with the engine design. So you can't vary that willy-nilly. It takes a lot of engineering time, interview time to do it and approve it, which adds to the profitability side of the equation, which just makes it even harder to come up with a new fuel system or a derivative fuel system in this case.
Yeah. So Cessna is marking a really interesting 50th anniversary of their Cessna Model 500, which essentially transformed their companies. You know, they went from just a general aviation manufacturer to more of a business aviation company. So, right. I mean, Alan, what sticks out to you as being prominent about this 50th anniversary?
Well, a lot of the Cessna Citation line hadn't varied until the 2000s, late 90s, 2000s. Citation 10 probably being that first real deviation from the Citation 500. But that's a very simple aircraft in today's terms. Essentially straight wing, simple fuselage, simple layout, pretty easy to fly. It's relatively simple to manufacture, and that's why Cessna makes basically that same airplane in different derivatives today, is that they can control the cost and it can be manufactured pretty easily. The kicker, I think, on the 50th anniversary on the Citation itself, the baseline Citation, is there hasn't been a lot of changes in the aircraft airframe design since then. On the business side, obviously we have the much larger aircraft with the Gulfstreams, the 3s, 4s, 5s, plus and the Dassault and Embraer have been making airplanes, but they're basically the same airplane. We haven't seen a lot of changes to that real fundamental Citation design in a long time. We obviously, things have got bigger, engine performance has changed. We sweep back the wings now, but it's not like we're talking about in the eVTOL market where there's going to be significant change on the way aircraft fly and handle. The basic Citation 500 design is still in play today, which it is interesting to consider, since that first, from 1903 to late to the 1970, there was a huge change in the way aircraft were built and designed. And then when we get about 1970, it kind of stopped. Materials changed somewhat, but there wasn't huge changes in aircraft. So I think the 50th anniversary comes with, it's sort of a double-edged sword. It's great it's been in production and that baseline design has been around that long, but the bad part about it is we haven't really advanced aircraft design all that much. So hopefully we'll see some more advanced designs coming up in the next couple of years with the eVTOL market.
All right, so in our engineering segment today, we're going to talk about a pretty interesting article by Michael DeCourt. This article that he penned just last week or this week in January. He's worked for Lockheed Martin, the U.S. State Department, the Navy. He's been in IT for a long time with aircraft simulation, stuff like that. So his perspective in this article for Urban Air Mobility News.com was pretty interesting. So obviously with Silicon Valley, a lot of these startup companies, and obviously we've talked about the eVTOL market being heavy on startups who are trying to get their product to market. You know, if you listen to any of these stories, like one of the podcasts I really enjoy is How I Built This by NPR and Guy Raz. And it's this common ideology of like, hey, we just need to get a prototype out there, even if it's not perfect, even if it's kind of like a beta. You know, our first product testers are almost like beta testing it for us in the open market. You know, Mr. DeCourt here is arguing that that's not going to work with the eVTOL situation, because obviously, and Alan, you know this well, if there's one crash where one person's killed, one family, you know, dies, that's going to really set back the entire industry. And of course, there's a lot of other implications there. And he talks a lot about ground and air, just the chaotic nature of communicating between those two types of transportation as we try to introduce, you know, aircraft into our, you know, city centers essentially. Right. So Alan, what was your take on this article? Because it was really interesting. It was really well written, I thought, and brought up a lot of really good points. What's your take on Mr. DeCourt's article?
Well, it first brought up the MVP process of Silicon Valley companies. I don't know if you've heard this term before.
I haven't.
The minimum viable product.
Oh, minimum viable product,
right?
Yeah, for sure. I've heard
right,
that.
So
yeah. Just not the acronym.
Right.
Yeah.
It gets tossed around. Well, we just need an MVP to get out the door. And in software, on an app on your iPhone, it doesn't really make all that much difference, right? The app may not perform as well as you would have intended it to, but it's functional. It's that first generation, get it out the door. Same thing happened with Macintosh and most computers today. That first product is never like the current generation. On aircraft, you can't really do that. You can't have a aircraft that sort of flies. You have to have an aircraft that has extremely high reliability. That's part of the certification of it.
Yeah, look, only 1 out of 70 of these goes down. That's only like 1.5%. That's great, right? Yeah, that's 98.5%. It's an A plus in middle school.
That's right.
Yeah, that doesn't work.
Right.
Yeah.
Remember when the iPhone had the problem with the antenna? You'd lose the cell phone coverage.
If you held it, you were holding it wrong.
Right.
Yeah.
Right.
Yeah.
And Steve Jobs comes out and just says, "Yeah, all phones are like that." In this case, you can't really have that, right? You can't say, "Well, Bob's aircraft fell out of the sky, so ours can fall out of the sky too." It's not like that at all. But that philosophy does permeate the engineering groups in Silicon Valley area. It's not very hard to see that term used and thrown about a bit. And if you watch newly developed components, apps, software, whatever come out of Silicon Valley, even Teslas, right? Those first Teslas were not the most reliable things on the planet. So it does become a design philosophy to just get something out the door. And you really can't do that in aircraft because you're right. The consequences of having an accident or an incident are so high on the valuation of the company, you just can't afford it. So you really need to find people that have the right philosophy and the right design approach early in the aircraft design. Otherwise, you catch problems much too late, and it just costs you 10, 100 times as much to fix. This is why I always say one of the most important groups in an aircraft design are the system safety people, because they control how much and what goes into an aircraft to make it safe, make it reliable. They're looking at reliability. And if you don't have that, or you're not thinking that way, then the aircraft just is never going to get to, one, certify, and two, be reliable out in service. So yeah, there is a lot to say about the way you transition from one industry to another. I don't think that really works all that well. And we saw that years ago with Eclipse. Eclipse was sort of a Silicon Valley, Microsoft company in terms of
the darling, right?
Yeah.
Backed by everybody important,
right?
Endorsed by John Travolta, and wasn't he one? I think he was one of their endorsers, wasn't he?
I think it was Travolta or was Tom Cruise, one or the other. I think they were both there.
One of the two, either way. Super A-list actors, and
right.
And we had DER Hector Del Aguila on the show, and he talked about that whole thing, sort of running out of steam and running out of money, and it becoming a very chaotic environment. So
sure, they thought they could design their own software system. Well, they did. The computers that flew that aircraft, they were going to design them, and they're going to design all the avionics at some point. That was the intention. Yeah, you can't do that. The issue is it meet all the reliability numbers? That's the hard part. And if in that case it didn't, so it struggled. It struggled for a lot of different reasons, but that was one of many that it just felt like they were making computers and not airplanes. It happens.
Well, and speaking of that, in this article, one of the interesting things he suggests as the way forward is doing a lot of simulations, which kind of reminds me of any of these sci-fi futuristic movies like Blade Runner, where you see these flying cars. The movie The Fifth Element was a good example, where we need to actually simulate these eVTOLs coming and going while there's city buses. And obviously they're not talking about landing eVTOLs on the sidewalk. That's not what's in anyone's mind. But he's saying, look, we need to simulate with computer modeling, if we can, these chaotic environments and have outages and have issues with communications. And we need to see what happens when things go wrong.
Right.
That seems to be what his big thesis is here, that we have to be really ultra cautious about figuring out what's going to happen before it happens. Because if we test it out in real world, And in my mind, as I was reading this, I was thinking, well, yeah, like what if an eVTOL is ready to land and they get oh no, you can't land, or something unexpected happens, and
Right.
You're between buildings and it could just be a catastrophe.
Yeah. Flying between buildings is a mistake to begin with. And I think that there is a lot, when you look at the eVTOL imagery online, you see a lot of eVTOLs in places they are never going to be, because you're right, any slight wind shift or abrupt change to the aircraft performance could send it hurtling into a building or into a crowd of people, and that is just never going to happen.
So it was an interesting article. It does seem like there's a lot that has to be explored, and I think that segues pretty well into our final segment. So we'll talk about Lilium last, because I know you have a lot that you want to go through here. But first, let's talk about Elbit. So their Starliner UAS is going to carry out environmental protection missions in Canada potentially, and this is like a similar to like the Predator that the U.S. Air Force has, right. That same kind of design. But Alan, what sticks out at you about this Elbit? And as an Israeli company, it seems like they've got some pretty good technology.
Yeah, they have some great technology, particularly in the UAV drone market. Just because of where they are in the world, they need to keep alert on their borders all the time. But that also lends itself to shopping those designs elsewhere. And there's been a lot more drone usage for Border Patrol in the United States and Canada and Australia. There's a lot of unmanned air vehicles out there. The second part is the sort of monitoring the climate with UAVs. That has also been around for a number of years. NASA did it about 10, maybe even 20 years ago now, and they did it, I think it was with the Predator, an early version of the Predator, where they were monitoring thunderstorms and taking measurements around thunderstorms. So it is a valuable, relatively inexpensive way to monitor the climate, because it doesn't involve pilots and it's a huge aircraft and the fuel burns a lot less. So it's just a much cheaper alternative to some of the larger aircraft that would typically be used for those kind of measurements. It's a good use of the technology. I think we're going to see more of it as the reliability of the aircraft goes up, and it has gone up greatly in the last 10 years. But also the payload capability and the amount of data they can push up and down, that it lends itself to a variety of different tasks that may not have been envisioned when the aircraft was designed. So you see the aircraft evolve into these select little marketplaces to fill these needs that would be much more expensive to do with a conventional aircraft. So I think you're going to see that continue. And Elbit is just one of the players there, but Elbit is a big player there because they have a lot of the technology. So it's interesting to kind of keep your fingers on the pulse of that, because it changes so rapidly from year to year to year where they can use the UAV technology.
So moving on to Lilium, obviously this is such an interesting story evolving with them, because they seem like they're evolving into this darling, very well-funded startup. And we talked about Joby recently and the fact that they're also very well-funded. They keep a lot of their secrets close to the vest. They've also, published a lot of patents recently, because look, they're on the move, like they're pushing hard towards eventual certification. Right. And Lilium is doing the same thing. But what was interesting, so this story that you and I read on evtol.news, which is a great website if you're looking for EVTOL news, aptly named. But Lilium got a lot of bad press. I don't know if I would call it bad press, but some engineers in the German magazine Aero Courier and Der Spiegel, one of their big magazines, they had a bunch of engineers, 5 of them, basically said that what Lilium is claiming their EVTOL can do, it can't possibly do with the 36 ducted fans. Like the design, the power of them, it just doesn't add up that they can carry this payload at this speed. Like they're just sort of running the numbers with the data that's been released, and they're like, this doesn't look like it's going to make sense. Yet they still raised a ton of additional money after that publication released that. So, and then interesting news just in the last couple of days is that the CEO, Daniel Wiegand, confirmed plans to take the company public. So, lots to unpack here.
Right.
So, where do you want to start first?
Well, let's just start with the financial part of it and what is happening there. The going public is obviously a way to raise money, right? That's why you go public.
Mm-hmm.
It's just to raise cash to support what they are talking about, building factories. It's essentially it. It takes a lot of money to build a factory and get an airplane line up and running. But it also has a sort of a political feel to it too, where the German government seems to be involved on some level of trying to promote this aircraft, which is fine. I mean, they can do that. But there's always that sort of Theranos feel to it, where a lot of things are being said, but when you start talking physics and flight mechanics and ability to stay in the air for the length of time they're talking about, those numbers don't calculate. So what the marketplace does and what the engineers do tend to be two separate lanes. And at least in the United States, we have seen a number of companies think they're going to produce some great new technology advancement and can sell it to the marketplace. But the engineers on the other side are going, well, there's no way that's going to happen. and so now we're into that sort of dispute. It's not really a dispute because Lilium isn't making it a fight. They're just saying that the engineers who did that analysis don't have all the information in front of them to make the analysis. I don't think that's true. I read through. I actually translated the article and read through it. It's not back of the envelope kind of numbers. They've really done some digging into this, and they have to make some estimations, obviously, because they don't have all the information. But if you read the article, they're giving Lilium the benefit of the doubt. If there's a chance to give Lilium a benefit in the analysis, they do. And even with that benefit, they're saying the aircraft can only stay flying for about 5 minutes. And that, I think, rings true to me, that just the way that the system is set up and the amount of drag and whatever it's going to have, or it's not going to keep the aircraft flying all that long, because takeoff and landing eat up so much of the available energy in a storage battery, because essentially all your thrust that's equal to lift or the weight of the aircraft. So you're using a whole bunch of energy to stay aloft. Forward flight should be less energy. If you look at like the Pipistrel electric aircraft, you'll see those numbers. So there's just be a disconnect between the published numbers, what they say they're going to do, and the engineering don't align. And in cases like that, my take on it is to stop and address that issue and to show that it can do it. But Lilium's not doing that, which I think is a little telling, because they should be able to say, here's how we're doing it. And if it has to happen behind closed doors, fine. But when the engineers are saying the aircraft can stay aloft for 5 minutes, and you're saying it can stay aloft for an hour, there's a widely different results.
That's a big gap. That's a big
gap, right? We're not talking about between 30 minutes and 40 minutes. We're talking about 5 and 60. I don't think Lilium's going to play this quite right, and it makes you wonder when they go public, is it a way to sort of divert attention? And that's the way Theranos was playing it, is that they'd make announcements, they'd make publication, and all the journalists at the time, and I'm not necessarily equating the two, but the sort of the flow tends to be similar, is that the journalistic community doesn't have a way to evaluate any of this. They don't have the skill set. They just don't. And why they don't call up the engineers and say, is this real? Especially in Germany, call up one of the old retired Airbus engineers and say, hey, does this make any sense at all? Is it in the ballpark? They haven't done that. What the journalists have done is said, well, we have 5 engineers that dispute it, and we have Lilium that says, well, they don't have all that information. Well, somebody's right. right?
Mm-hmm.
And so the way this is playing out is weird.
Yeah. And it does sound sort of reminiscent of the Theranos situation, because Elizabeth Holmes, the CEO, she kept saying, or she just kept like moving on. People were like, we want to see it work. Let's see the machine. Let's see the machine. And she just like kept everyone moving, saying, oh, you got to get on the train. Like, so, people were in a fury to, that's not the right word, but there was like this froth built up where everyone's like, I just don't want to miss the train. Like, here's my money. Like, I'll invest it.
That's
Even though I
true.
haven't seen it. Like, I just don't want to miss this boat. And that was what Walgreens said at the end, where they're like, we just really didn't think it through, and we just didn't want to miss out on this opportunity and have some other big company beat us to it.
That's right.
And so everyone kept throwing money. But she never, like, no one ever saw the machine work. That was the crazy thing. And people started to be like, why can't we see it work? Let us see it work. Just show it to us. They're in the other room, bring them in. And it just never happened.
Never happened, or they fake it, or they would fake it, right?
Mm-hmm.
They would fake it. And
Yeah.
part of that sort of process that happens is, from what I have seen on similar situations, is they put people on the board who are very powerful, and they have lawyers who can basically silence all criticism, which is what Theranos did. Right? They went out and they silenced all criticism by sending in threatening letters, made the employees sign these non-disclosures, threatening to sue former employees who talked about anything they did or saw at Theranos. So it kept this cocoon. I'm feeling that cocoon going on. I feel that cocoon going on in a couple of these eVTOL companies right now, where no one's talking about what actually is happening. Like some of the flight test stuff. If they're flight testing aircraft, there must be people around there who see the flight tests go on and must know, right? There must be more than 20 people at any at these sites that are flying these aircraft to know that, yeah. And one of the weird things that happened this week, I don't know if you caught it, Dan, was there was a news story about the Kitty Hawk Heaviside aircraft, and I thought that was fascinating because they were showing some of the fuselage shells, or the aircraft shells, the carbon fiber shells there. And they were talking to the CEO of I guess it's Wisk, I guess, for the Heaviside. And what he was saying was the flight duration time, and don't hold me to this, but it sounded about right, was like, or the flight distance time was maybe 100 miles, one person. So it's a smaller aircraft, one person. I think it would set it at 100 miles. How do we do that when we put 4 or 5 people in? Right? Like when you start multiplying the number of bodies inside these aircraft, although the weight goes up, and then what do you have? Can you do 100 miles when you got 4 former people in the aircraft? I don't think so. Right? The math doesn't work. Right? So when I saw the Heaviside little snippets, I thought, wow, that's, there's a baseline. And Pipistrel says the same thing, by the way. Pipistrel, if you look at their data sheet makes sense. You can actually run the numbers and go, yeah, okay, all this makes sense. We don't see those sort of things out of a couple of these larger eVTOL companies right now, and it starts to get worrisome.
Yeah, and they might just be buying time. And of course, you see this with some of these consumer electronics, like we've talked about. For example, like I own an electric scooter. We've talked about it, little bits and pieces. But if you read some of the specs on like these electric scooters, they'll say, it can reach a top speed of 17 miles per hour and go 12 miles on a charge, asterisk. And the asterisk is like, well, if you're 135 pounds, if you as one human are 135 pounds. So okay, well, I weigh 200 pounds. So how far does that get me?
Right.
Well, I only get 15.2 miles per hour top speed and 7 miles of range because I'm not their prototypical human. So when they say 2 people, does it mean 2 average Americans, where average Americans weigh 375 pounds? Or does it mean, average, French person where they slim and, svelte? So,
right.
Yeah, it's, they tend to massage those numbers with some of those consumer things, but ultimately, as we talked about with aircraft, they're going to have to say, when it's ready to go, like, this is our capacity. This is like, these are the real numbers, because they're not going to load people in there and put luggage in there and have the thing go down. Obviously, like, they're going to be very forthcoming at some point, right?
They have to. And as soon as they don't meet numbers, then on a publicly traded company, the value will collapse. If they're not anywhere close to those published numbers, it'll collapse relatively quickly. What has been bouncing around in the back of my head the last couple of months on the eVTOL market is the addition of a secondary power source. If it's not battery, if battery won't get them where they want to go, do they add a little turbine engine generator system that burns Jet A or 100 low lead fuel, or does it burn hydrogen or something to basically put a lot more energy storage onto the aircraft and get it to fly further? That makes it really starting to feel that way, because everybody's in hiding in terms of what the technology is. And if it's still electric, but there may be this hydrogen element to it, or there may be this temporary Jet A element to it until the battery capacities can get increased. Those are all possibilities now. And I don't think it defeats the purpose of the aircraft. I don't think it does that at all. But it does change.
Because it doesn't have to be, it doesn't have to be electric. It's not like, this is going to, if it's not all electric, it's going to destroy the planet. It's just going to be another small, contributor to greenhouse gases and all that. Like, no one said these have to be electric. They're just doing it because that technology is getting pretty close, right?
Right. And all aircraft go through that initial stage. Like we were talking about the Citation 500, when that was initially designed and certified way back in 1971.
It's a steam engine.
Essentially. In terms of the jet technology they had then compared to now, I mean, that's just completely different in terms of efficiency wise. Why can't the eVTOL market go through that same transition? I don't know. But one of the things that's starting to worry me a little bit is how fast takeoff needs to be, how little time they want to spend in hover, because it eats up so much power, and what that means in terms of the controllability, piloting aspect, because you want to go from essentially, to keep the burn down on the energy usage, you want to go from 0 to cruise flight as fast as you can. And the way that some of these aircraft are designed, Joby, Wisk, a number of them, is that the wings don't provide a lot of lift. They provide lift at cruise speed, and if that's the case, then your takeoffs and landing are going to be very exciting. They will be very, very exciting.
Well, and the last thing I want to bring up is, one common, I guess it's an old adage, is they say don't attribute to malice what you could just attribute to incompetence, right, or stupidity, right? So with some of these companies, like obviously Theranos, that was a legitimate scandal. Like they defrauded investors and everybody.
She didn't have the capability to make any of those decisions at all. She knew nothing about the technology.
She was just like the front person, essentially. She didn't have a background in any of that technology.
Exactly.
But with all these companies, just because they seem like they're keeping information close to the vest, maybe they don't have it all sorted out yet. They might know, like, we're just not right there. So we just got to keep this close. Even though we're getting criticized, there might not be any sort of like, might be anything perfidious going on, but just the fact that we feel like we can solve this solution. We know we're not right there yet. People have kind of figured it out in the public that maybe we can't meet some of these claims. So we're just going to like keep it to the close to the vest until we can, because we really believe that we can do it. So it could just be something like that going on. I mean, with all these, they can't all just be.
No,
you just give them the benefit of the doubt, which I know you are. It's just a situation where who knows what their internal process is trying to get all these solutions, which are all very different, just finalized and to do what they hopefully say they can do. But as you said, many of them probably can't do what they're claiming to do right now. And so they might just be in this situation where they're just like, oh man, we've made a lot of promises to a lot of people and this isn't working. How do we save face when we have all this amount of money? That's got to be a really scary hole to dig yourself into as a company founder, where you're like, I've told a lot of people this is going to work and it's not going to work. What do we do now? That's got to be a terrifying situation.
It is. I've been around a number of aircraft companies that have been through that process on conventional aircraft, and the discussion kind of goes like this. We put out published numbers, and what are we going to do? We're not going to make those numbers. Aircraft's too heavy. It burns too much fuel. What do we do? But those numbers are not off by a factor of 5, right? They're off by 5%, right? And then that's a big deal. I mean, that's sort of conference room staple throwing time. But in these cases, we could be really far off unless there's some other technology advancement that could explain how they're going to accomplish these things, because we haven't seen it. And all it takes is, I was having a discussion about this over the weekend. All it would take to get rid of all of this is a test flight.
That's true.
We have the ability to shoot a 60-minute video. Great. Fly the aircraft around in circles like the Wright brothers did back in 1908 or whatever it was. Just fly it around the field for 60 minutes and land it. That's all we ask. Let's see if this is really true. And that solves it all. But we don't have that yet. And it starts to worry me that we don't have that. Why not? We should have that. If you're really going to be able to produce this aircraft and deliver somewhat close to what is really promised, then all it takes is a YouTube video. That's all it takes.
Yeah. Yeah, that's true. Yeah, and it's just an interesting situation where, like you said, if it falls so far short, because with a lot of these eVTOLs, they might need to, their business model in the future might be getting someone from Long Island onto a rooftop in Manhattan, right? And so they've got to make that, whatever it is, 42-mile journey to fit the business model. And if they can't do that, so now they fall very short of the numbers. They can only make it 26 miles on a charge. It's like this whole thing collapses. So that's support for that sort of theory of chaos, but also your point of maybe we just need to put another secondary power source in this so we can always make that flight. And then when battery technology improves, then we're good to go. But yeah, that's the big scary thing, is if they can't make that leg and fulfill essentially that mission of short distance flights, then they've got nothing.
I kind of wonder if the short distance flights are going to be of enough value to keep an aircraft company going. Uber Elevate closed because I think there's a reason why Uber Elevate closed. Obviously, COVID didn't help their overall business, and the automotive business isn't doing super well at this point. But at some point, somebody in the back rooms at Uber Elevate had to sit down with a calculator and go, this is possible, this isn't possible. What are we doing? And if we Uber are going to invest in this, then it's time to pony up and show us you can do this, or we're not going to be around anymore. I have that sneaky feeling that was part of the whole closing of Uber Elevate. Was a lot of these companies are promising a lot, but
we're really far away.
Right. And you saw that with Jaunt recently. What Jaunt has hooked up with a company to do what I'm just talking about, basically provide a secondary power source to their aircraft to extend the range to where they can be a value proposition for sort of those medium length flights, those 100-mile flights. The reason Jaunt's doing that is because batteries won't get them there today, but they may in the future. And overall, the whole system is a lot more efficient than aircraft we use today, and it costs a lot less to operate. What's the problem with putting an additional power source besides the added weight? But what's the difference to putting a smaller additional power source that burns some sort of hydrogen to extend the range? I don't see that stopping the marketplace, but boy, oh boy, it sure is quiet right now.
All right, well, that'll do it for today's episode of Struck. If you're new to the show, thank you so much for listening, and please leave a review and subscribe on iTunes, Spotify, or wherever you listen to podcasts. Check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from the show. And follow us on LinkedIn, Twitter, Instagram, and Facebook. Our handle is @WGLightning. Tune in next Tuesday for another great episode on aviation, aerospace engineering, and lightning protection. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.